Our topic for this video is a system of linear equations. What that means is we have two lines. This particular form, where we have our x term combined with our y term equaling some constant, is called standard form. What we should do first is convert each of these standard form equations into slope-intercept form. So let's do that first. Get 3y equals 2x plus 8. We divide by 3 and we get y equals 2/3 x plus 8/3. So the first line has a slope of 2/3, rise 2, run 3, and a y-intercept of 8/3. Our second line, 3x minus y equals -5. Negative y equals -3x minus 5. Divide by -1 and we get y is equal to 3x plus 5. Now this step is important because immediately we can compare the two slopes. Once we determine that the lines have different slopes, we can go ahead and solve. And what we're looking for when we solve is the point of intersection. So that's what we're after, an x value and a y value. So let's solve for x and y. The first method that I'll demonstrate with this example is combining. If I just combine these two, I would get -2x plus 3x gives me positive 1x. 3y minus y is plus 2y, and 8 plus -5 is 3. That's perfectly legal and that's all fine and good, but I did not get rid of a variable, and I want to eliminate a variable in this technique. So what I'm going to do then is sort of plan before I write my next step to get a zero pair. And I can see that if I multiply the second equation by 3, I can take the first as is, and then I get 9x minus 3y equals -15. And now when I combine, I get 7x. Here's my zero pair. Positive 3y, negative 3y gives me 0. And now the constants 8 plus -15 is -7. And now I can divide by 7 and get x is -1. So that's the key to this combining equations technique, is to obtain a zero pair, which will eliminate one of your variables. And now to finish, I substitute -1 in for x. Let me try the second equation right here. 3 times -1 minus y equals -5. That's -3 minus y is -5. Negative y is -5 plus 3 is -2, and then I get y equals 2. So the point of -1, 2 is my solution. Same problem. This time we're going to use a new method. So let's remember again that our slope-intercept forms were y equals 2/3 x plus 8/3. That's the slope-intercept form of equation 1. And equation 2 has the slope-intercept form of y equals 3x plus 5. This is a very good first step because we can immediately compare the slope or the steepness of the lines to determine if they will intersect. If they have different slopes, they will intersect. Now method 2 is substitution. And now what I'm going to do is, since this expression for y does not have any fractions, it's not too terrible to work with, I'm going to substitute it into the other equation. So if this is equation 2 in slope-intercept form, I want to substitute in for y this expression. So now my first equation, -2x plus 3 times y, I'll replace with 3x plus 5. Distribute, combine like terms, subtract 15 from both sides, and we get our correct answer of x is -1. And once again, I substitute this back in, as I did in step 1, to get -1, 2 as my solution. Let's look at the graph of this problem. If there was any confusion about the importance of the slope-intercept form, we can see that the blue line has a slope of 2/3 and a y-intercept of 8/3. The green line has a slope of 3 and a y-intercept of 5. And here is our solution, which is the intersection of those two lines at -1 for x. You can see the x value is -1 for this point, and a y value of 2. And here's a biconditional statement to summarize this type of system of equations. A system of equations has a solution if and only if the lines intersect. Example 2, we have this system of equation, and again our first step is to put them in slope-intercept form. -y equals -4x plus 8. Now divide by -1 and I get y equals 4x minus 8. So that's equation 1. Equation 2, I start with 2y equals 8x minus 5 and divide by 2. And already I can see something which should stop me in my tracks. If we have an equal slope, we have two possible outcomes. Either the lines are parallel, which means there are no solutions, or the lines coincide, which means they're the same line. And in that case, we would have an infinite number of solutions. So in this case, how can we determine? We compare the y-intercepts. -8 is not the same y-intercept as -5/2, so we have our parallel lines. Let's verify by looking at the graphs. Here's line 2, here's line 1. We can see that they're parallel. And lines with equal slopes and different y-intercepts will have no solutions. They will not intersect because they are parallel. Example 3. Here's our system of equations. And again, A really nice first step for these problems is to put them in slope-intercept form. First one gives me y equals 3x plus 2. The second one, I start with 2y equals 6x plus 4. And now when I isolate y by dividing everything by 2, we get the exact same line. So this would have infinite solutions because the same line with itself is what we call coinciding. Thanks for watching. Keep practicing.